I was talking to a guy the other day, a really nice guy, but didn't understand the difference between voltage imbalance on three-phase and why it was important. So let's do a quick little video today on the importance of that and checking it. So you can spend the rest of your life learning about electrical theory, and it's all interesting, but we're just going to break it down to make it as simple as possible. On power generations from a motor, from that motor spinning it through the windings, which is where you get degrees of that rotor. So you have a 90 degree, 80 degree, 360 degree. And out of that motor, we're having three different power wires, three different phases: first phase, second phase, and third phase. Because we keep all three phases powering that motor at the critical points, we don't need a capacitor. We're getting full power on that motor all the time, which makes those motors extremely efficient and extremely powerful. The problem is when we get one of these phases out of balance, it can definitely damage our motor. I've seen this before. I've seen techs before go out and replace semi-hermetic compressors or very large centrifugal blowers, and they never check to see why that motor failed. And lo and behold, they go out and have to replace that motor again, and then they're complaining about the brand or the quality of the rebuild. And the real result being the system was the phase was out of the safe side on the phase. So it's very important to check that. It's a fairly simple little process to check. When you're dealing with these three-phase motors, it is a critical thing to check. On a three-phase motor, we'll have line 1, line 2, and line 3. On this example, I wrote it out. We've just checked voltage between line 1 and 2 being 208. Line 2 and line 3, 210. Line 1 and line 3, 206. So I drew it out this way as well. Some people prefer to see it this way. Some people prefer it this other way. But between line 1 and line 2, I wrote down 208 volts. Between line 2 and line 3, 210 volts. Between line 1 and line 3, 206 volts. So these numbers look like they're pretty far apart, but what we're going to do is average them out. I add all of these numbers together, I get 624 volts. I divide it by 3, my average voltage I'm working with is 208 volts. So now that I know my average, I can look between my farthest point, which is in this case 210 volts, to that average, and I see that my largest voltage imbalance that I have on this one is 0.96%. So I know that my voltage on this system is working actually fairly well. So the U.S. Department of Energy suggests that we have less than a 1% voltage imbalance, which is what we have, and that's great. Fluke Energy or Fluke meters, they suggest less than a 2% voltage imbalance. But certainly, industry standard, you never want to have more than a 3% voltage imbalance. 3% is critical. You're looking at replacing that motor. So when we do the math on 208 volts, we come out to an average percentage of 208, 3%. That means we could have a voltage imbalance of 6.24 volts. And in this case, between 210 volts and 208 volts, we are within that range. It's a fairly simple thing, but it's absolutely critical that we keep this voltage balanced. Now, the next thing is we have a voltage imbalance. What do we look for? And really, it's the same thing we should look for with every unit, whether it's commercial, residential, three-phase, or single-phase. And one of those things is checking all of our electrical connections. That's our number one problem of failure anyways, is loose connections. So we want to check the contactor. We want to check the points on it. We want to check the wires. We want to check all the connections coming into that unit. We want to check all the lugs, any of the wire nuts, any connection going through there. We want to make sure all those connections are very secure and have the equal amount of conductivity between all of them. Even something like a fuse block, where the fuse block, somebody's replaced it several times, popping that new fuse in and out can cause the clamps that clamp that fuse to become loose. And if you have a loose connection, with a voltage drop and heat, that voltage drop can easily throw your imbalance off. So the most important thing we want to do is check all of our connections in a unit, especially those contactors. We know that those will burn out. We want to check those for sure, check the disconnect, everything up in that disconnect. If we still have a voltage imbalance, that's where we're going to have to talk to our electrician or the building maintenance. On that point, they need to look at their power grid. Maybe they have a line, somebody added on a line, they have a whole lot of extra usage on one of these phase lines. And on one of these phase lines, they're having a major voltage pull. A large amount of amps on there can cause a voltage drop, and that can throw the system out of phase. And sometimes it's also coming from the electric company. In that case, either way, whether it's a voltage imbalance from the building or for an electric company, the electrician needs to determine that. But the simple steps we want to do before we call them in is make sure everything is good on their side. That disconnect, the contactors, connections, fuses, wire nuts, lugs, all the way into that motor, and the wires as well. Make sure there's no burnt wires. We have seen many times notoriously where somebody will have a bad wire, they'll put a new crimp on it, but they don't clean that wire back, and you'll have a damaged piece of wire inside. So we want to make sure those wires in that three-phase are all in good shape. Make sure that we're within, ideally, less than 1% voltage imbalance. At the most, no more than 3 for sure. It's definitely a danger zone. There is an older school method that I was once taught. That if you have a motor and it's running and you have a pretty decent imbalance, it can wear on one of those windings of the motor more than the other, which can cause, which was really damaging the motor. But after they get the voltage imbalance fix one of the connections, I was told that you can take the line 1, move it to line 2, take your line 2, move it to line 3, take your line 3 and move it back to line 1, and you've basically shifted your entire phases through that motor. And you may have to do that one more time, and you may end up going back to the original setup to make sure it's right. We know if we move any 2 legs, then we're going to reverse the rotation of that motor. But if we move all of them one stage over, keeping them in the same distance apart, then we can actually rotate the phase in that motor, and sometimes that will help balance out the phase. Not going to be guaranteed. You want to check with the motor and manufacturer to make sure they allow that first. But some of the little tricks out there that you don't see written off too often. So hope that can help. Hope that helps from having to have a warranty motor or motor callback, or even maybe save some motor failures. So if you have any questions, please let us know. Thank you.